Alright, we're going to talk about next is the power rule for exponents. And the power rule for exponents is that if I have a to the x power to the y power, what I do is I take my a and multiply the x and the y. And what's happening is that if I have on this problem p to the 8th to the 3rd power, is I'm supposed to multiply the 8 and the 3. The reason why is because this really turns into p to the 8th times p to the 8th times p to the 8th, because I have 3 p to the 8ths. And if I was to add those like I was doing before, I would get p to the 24th power, like the product rule shows us. But the shorter method is to take p to the 8th power and times it by 3, and that also more effectively gives us the 24. So on this next problem, you can see that I've got 3y to the 4th power, and instead of writing out 3y 4 times, I can just distribute the 4 to both of the 3 and the y. And because the 3 is to the 1st power, it's just 3 to the 1 times 4, but you don't really need to write the 1 times 4, times y to the 1 times 4 also, or just times to the 4th. And so the answer would be 3 to the 4th, y to the 4th, and if you can, simplify the 3 to the 4th to get 81, y to the 4th. Now on the next problem, you can see that I've got a fraction raised to the 4th power, and what's happening is you really have 2/3 written out 4 times. And instead of doing this every time, you want to notice that I'm really just having 4 2's and 4 3's. In other words, I can distribute the exponent and just make this 2 to the 4th over 3 to the 4th. And then once you get those, you just want to go ahead and simplify and figure out that 2 to the 4th is 16 and 3 to the 4th is 81. So let's continue with some more examples here. I've got 6p to the 7th and then the whole thing squared. Now what I'm supposed to do is take my 2 and distribute to the 7th and distribute it to the 6th, which is to the 1st power. Now the biggest mistake that I see is that people take the 6 and times it by 2 and they get 12. Now that's, and they'll get the p part right. They'll do p to the 14th, which is correct, but this is what they'll put as their answer. And that's not correct because the 6 isn't supposed to get times by the 2. It's supposed to be 6 that's to the 1st power, and that's getting times by the 2. So this should actually be 6 squared p to the 14th. I'm sorry, I wrote 6 to the 6th. 6 squared is what I meant to write. So 6 squared p to the 14th. And then from there you should actually simplify to get 64 p to the 14th. So let me back up. And when you square or distribute the 2, I want to get 6 squared and then distribute it to the 7th, so I get p to the 7 times 2. Okay, so that would be the first way. This would be the way that you should do it without making that first mistake that I was showing, where you multiply the 6 and the 2. So I get 6 squared, and I get 64 p to the 7 times 2, which is 14. Okay, so this would be your direct way of getting your correct answer. On the next one, I've got this 3 to distribute. Now there's lots of things I need to distribute it to. I need to distribute the 3 to the negative 2, the m, and to the z. Now, I said in the last lesson that if you have a positive or a negative and you raise it to an even power, the answer will be positive. Now here we've got a negative that's being raised to an odd power, and the answer there would still be negative. So it doesn't actually matter that I'm raising the negative to the 3rd power, it's still going to stay negative. That's what I'm trying to express here. So we get, still going to be negative, 2 to the 3rd power, m to the 5 times 3, over z to the 3rd power. And then we need to further reduce to get negative 8, because 2 to the 3rd is 8, m to the 5 times 3, which is 15, over z to the 3rd. And that part didn't change. And that's your final answer for that problem. So now what we're going to start doing is getting a mixed group of these exponent rules, and that's why I've given so many examples of each type. There's so many different little things that can happen, and then we start combining them all together, like this problem. I've got 3 squared times 3 to the negative 5. Well, the product rule says that I should just add them, and the other rule I was saying, well, I have a negative exponents. We don't like negative exponents. We like them to be on the bottom so that they turn positive. So there's many ways we can go here. The shortest way would just to say 3 to the 2 minus 5, because it's really plus negative 5, and that would give me 3 to the negative third. But I wouldn't leave it here. I would turn it into 1 over 3 to the third. And of course you'd want to make it 1 over 27. You could have also said, well, this is really supposed to be 3 squared over 3 to the fifth. And then I'd reduce and say, well, this turns into a 1, and this turns into 3, and then I turn it into a 1 over 27. So there's 2 ways to go. Neither way is more right than the other. They both get you to 1 over 27. So we start combining all of our rules together, so hopefully this doesn't get too confusing for you. So let's check out this next one. Got a negative 5 exponent. Now, before I start moving stuff around, I want to go ahead and distribute this. I'm sorry, just to the negative 2 there. And that gives me 4 to the, when I multiply negative 2 times negative 5, it gives me positive 10. So that, I didn't have to flip anything, even though they look like it was a frown and ready to turn upside down. It actually, when I multiplied, turned into a positive exponent, and so I stop right there. Now in this next problem, I've got a little bit more simplifying to do. So I've got x to the negative fourth, y to the second, over x squared, y to the negative fifth. Now before you start canceling, because I know our eyes start saying, oh, I can cancel those 2 with 2 of these, and so on, I don't want to do that until I have positive exponents. This is a negative 4, that's a negative 5. This needs to move down, this needs to move up. So that turns into y squared times y to the fifth over x squared times x to the fourth. And now I don't have negative exponents, so now I actually just combine these to get y to the seventh over x to the sixth. And then there's nothing I can do. That'll be my final answer. And as you can see, we're working our way up and we're getting even more complicated problems here. Now notice this one. I want to take my 2 and the negative 1 and distribute those first. I'm going to distribute the 2 to all 3 of those inside that parentheses, and I'm going to distribute the negative 1 to all 3 of these inside this parentheses. So this will give me, on the first fraction, 3 squared x, and this will give me 2 times 2, which is 4, and then y squared. And then the second parentheses will be 4 to the negative 1. This will give me x to the negative 3, and then I'll have y to the positive 2. And then the way that we do fractions is that we'll multiply straight across eventually after we cancel stuff, but before we do that I have to have all positive exponents, so these need to move down to the bottom. So I'll rewrite to be 3 squared x to the fourth over y squared times 1 on top over 4 x to the third y squared. And again, the way we multiply fractions is we multiply straight across after canceling, and I can cross cancel with this x to the third and the fourth on top. I can cancel out 3 of the ones on the bottom with 3 of the ones on top, and there's a 1 left over, so it's x to the 1, and that's as much as I can cancel. So on the top I'm going to have 3 squared, which is 9, over 4 y to the fourth. Because there's 2 y's here, there's 2 y's there, I add those to get y to the fourth. That's my final answer for that first problem. I'm going to erase and do the second one. The second one, there's lots of things to distribute this negative 2 to. Everything gets a negative 2. So I distribute here, and we'll talk about the negative sign in a minute. The 5, the 4, the 24 will get a 2 up here, and then this will get a negative 2 also. So everything gets a negative 2. Now, when you take a negative and raise it to an even power, that will turn into a positive. So that was something I said on one of the previous lessons, so you got to be really careful about that. that does make a big difference here. That negative sign turns into a positive. So it's gone. I just can cross it out right now. And then I'm going to rewrite everything. 4 to the negative 2. M to the 5 times negative 2. Actually, I'm just going to go ahead and do the math on that and make it negative 10. N to the 4 times negative 2. That'll give me negative 8. Over 24 to the negative 2. M to the negative 2. I'm sorry, I didn't write that down here. Negative 2 to the m. And then n to the negative 2. Now that I've distributed the negative 2 times 7 on that last one. So that'll give me a positive 14, actually. So negative 7 times the negative 2 gives me positive 14. Now that I have all my distributing done, I'm going to go ahead and flip everything that is negative and make all my exponents positive. So then I get 24 on top. I'm going to get m squared on top because it needs to go up. And then the n stays on the bottom. So that's all that's left on the top. The 4 goes down to the bottom. So it's going to be 4 squared. And then the m to the 10th will go down on the bottom. The n to the 8th is down on the bottom. And still we have this n to the 14th. So 24 squared, sorry I didn't say that, I wrote it, is on top. So if I can figure out 24 squared and then simplify from there with the variables. So on top, the 24 squared gives me 576. And then I'm going to get m squared. I'm sorry, let's cancel the m squared. With m to the 10th on the bottom, that turns into an 8. So then on the bottom I get 4 m to the 8th. And then I multiply my n's together. And because it's 8 and 14, I just add those to get n to the 22nd. So I've done all my exponents. And the only thing that's left is if I can simplify the 4 squared, which I'm sorry I should have written 4 squared, out as 16. And then if I can divide the 576 divided by the 16, that'll reduce this to be a 36. So my final answer, which I don't have room for, let me erase some stuff. Final answer will be 36 on top, because 576 divided by 16 is 36, over m to the 8th, n to the 22nd. And that's as much canceling and reducing as we can do for this particular problem. So you can see it turns into a big mess that you have to really, and you saw me lose an exponent and then put it back because I was catching it as I was writing it down. Make sure that you pay a lot of attention to where your exponents are going, what they simplify with on the top and the bottom, and don't simplify until you got negative exponents turned into positive. So all your frowns have to turn upside down before you start canceling.